אוקיי, שלום לכולם, ברוכים הבאים לוובינר של מקיט, בשיתוף עם בנטלי. היום אנחנו הולכים כמובן להציג את הפלקסיס LE, ואנחנו נעשה איזושהי מצגת פתיח קצרה, ומיד נעבור למצגת של דוקטור מורי יחד עם פאסל. אז קודם כל, מי שלא מכיר, אני שרון מחברת מקיט מערכות. אנחנו נציגים של פתרונות בנטלי וסימנס בארץ. מקיט היא קיימת בשנת 85, אנחנו ספקים של שתי ספקים עיקריים בעצם, סימנס וכל עולם התכנון המכני, כאשר מדובר על כמובן החל משלב הייצור של חלקים מכניים, עיבוד של חלקים וגם כנושא של ניהול המידע ההנדסי. בעולם של בנטלי אנחנו כמובן בתחום של תשתיות ובנייה, ומקיט מערכות היא חברה בת של מלמטים, אנחנו ספקים של פתרון של הנדסה, אנחנו מונים כ-80 עובדים, ואנחנו מספקים שירותי מכירת פתרונות, ייעוץ, יישום ואינטגרציה, ניהול פרויקטים, הדרכה והטמעה ותמיכה טכנית ללקוחות שלנו בכל ישראל. קצת על חברת בנטלי, היא מספקת פתרונות תוכנה אינטגרטיביים שתומכים במחזור החיים של פרויקטים הנדסיים במגוון רחב של תחומים. בנטלי כמובן חברה גלובלית, היא קיימת כבר מעל 30 שנה, מונה כ-4,500 עובדים ברחבי העולם, ומפיצה את השירותים ב-186 מדינות בכל רחבי העולם, עם הכנסות של קרוב למיליארד דולר בשנה. זה איזשהו overview של כל הפתרונות של בנטלי. למעשה יש פתרונות אינטגרטיביים בכל כמעט סוג תשתית הנדסית שיש. כמובן שכל התוכנות הן תומכות בשיטת בים, וכמובן כל זה עוזר לנו בתחום של הקרקע, שאתם כמובן מכירים. כל הנושא של פלקסיס LE, שלשמו התכנסנו פה היום. פלקסיס 2D ו-3D כמובן אלמנטים סופיים שאתם מכירים. פלקסיס דיזיינר, שזה בונה מודלים קונספטואלי, שגם כן נדבר עליו היום. ונושא של גינט, שכל ניהול הלוגים וניהול הדאטה של הקרקע. וכמובן כל הפתרונות של תחום הקרקע עוזרים לנו במגוון פרויקטים הנדסיים, שאתם מכירים כמובן, תחום של תכנון כבישים, כל נושא של אינטראקציה של מבנה וקרקע, מינור כמובן, ויציבות מדרונות. האג'נדה שלנו להיום, כמובן מורי יציג יחד עם פאסל את התוכנה. נקודה חשובה שאנחנו כמובן רוצים להראות, זה כל נושא של עבודה של פלקסיס LE, בשיתוף עם פלקסיס 2D אלמנטים סופיים, והיכולת העבודה המשותפת ביניהם, ככה שייתן ליועצי קרקע אופציה לעבוד בשיתוף המהנדסים הקונסטרוקטורים, ובסוף המצגת תהיה לנו זמן לשאלות. זהו, תהנו. נעבור למורי.
All right, thank you, Sharon.
You can take the lead. Thank you very much.
All right, here, I'll start sharing my screen here. There we go. There we go. All right. So thank you everyone for listening to this presentation here, coming out here. We're happy to be doing this for Mckit and pleased to be walking through some basics of PLAXIS LE. And we'll be going over the software a little bit in the overview type of way. I'll be doing a PowerPoint of the key features of the software, and then I'll turn it over to my colleague Facile to do a demonstration of the software and walk through the specifics of the actual features of the software. So my name is Murray Fredlund, as has been mentioned, and I'm happy to do a walkthrough of the software here today. So let's see if we can get this going. There we go. So yeah, as far as an overview, I'll do a little bit of an introduction, then we'll talk a bit of an overview, walk through some of the key functionality areas of the software. We're focusing on limit equilibrium. And so we'll be looking at things specific to slope stability today and the application of the limit equilibrium method for slope stability. We'll also look at some differentiating features and then talk a few brief examples. What are the benefits of the software? And then Vasile, as mentioned, will give a nice overview of the software. So how does PLAXIS LE fit into the Bentley team in terms of geotechnical software? We were originally, I founded Soil Vision back in 1997. That's a long time ago. And we had a product called SV Slope. And when we entered Bentley in 2018, that eventually SV Slope got renamed and rebranded in the marketing to PLAXIS LE, and SV Designer got rebranded as Plexus Designer. So we're really going to just talk about two products today out of the suite, PLAXIS LE and Plexus Designer. And as has already been mentioned, there's a whole suite of Bentley products that you can have access to. And we're going to talk a little bit of the interoperability between the packages. So what is PLAXIS LE? So PLAXIS LE is, at a high level, is 2D and 3D limit equilibrium package for performing deterministic and probabilistic analysis of the stability of soil or rock slopes. You can calculate the factor of safety, the probability of unsatisfactory performance of slopes, and the software is designed to be very easy to use, as well as have high advanced features that can model complex geometries and couple with groundwater seepage. So this is there's comprehensive support for reinforced slopes and external loadings as well. So it should be noted that the package tries to combine some of the classic features of the method of slices analysis, as well as implementing new probabilistic analysis and advanced searching algorithms. The software was developed by a great team of people that I had to hunt all over the world for in terms of limit equilibrium expertise, and it combines a sleek and simple user interface with advanced presentation of the results. So this presentation will focus on 2D. However, it should be noted that the majority of the features mentioned in the software have been moved over to a full 3D analysis. So in terms of workflow, the software works from left to right through the main menu system. So in other words, if the user progresses through the menu options in a left to right fashion, you will ultimately be guided through creating and solving an analysis. For boundary value problems, the primary focus is on three aspects of the model, which includes geometry, materials, and boundary conditions. So in a limit equilibrium, the boundary conditions could be line loads or distributed loads or seismic loads. And slope stabilization can effectively act as internal boundary conditions. So in terms of creating a new model and creating the geometry, a new model can be accomplished by importing objects or by drawing geometry polygons using CAD-like software features in the software. The line angle and slope and length is displayed during the drawing process. And grid and object snapping aids allow assurance that the objects join properly. So there's also a number of geometry cleanup tools. If you have drawn geometry maybe in a wrong way, or you brought it in from AutoCAD, you can correct it and fix the drawing so that everything exactly joins together and there's no gaps or no overlaps in the model. So there's a comprehensive list of constitutive models that guide the behavior of soil or rock within the model domain. There's almost 30 different constitutive models that are implemented in the slope stability software. There's also methods for estimating unsaturated seepage properties in the groundwater modeling module. So an associated Soil Vision Soils database has over 40,000 soils, allowing for a number of unsaturated soil properties to be selected based on data mining. So soil water characteristic curves can be easily generated for a wide variety of soils for the basis of unsaturated seepage modeling in the software. And that unsaturated seepage can be used to generate pore water pressures, which can then feed into your slope stability software. The software has a comprehensive array of searching methods for finding that critical slip surface. And the searching methods comprise both circular and non-circular methods, as well as optimization. So optimization further refines any particular circular or non-circular searching method to find the lowest factor of safety. So there's a number of different ways to put in pore water pressures into a slope stability analysis. Water tables can be used and drawn in the software. You can likewise draw piezometric surfaces, use R sub U values, or put in discrete measurement points, which are then interpolated between to have a continuous field of pore water pressures. And this is important because we know that pore water pressures are the most common contributing factor to a slope failure. You have a change in pore water pressures that affects the stability of the slope, and then there's a subsequent slope stability issue. There's also methods of handling unsaturated suctions in slopes. So in terms of loadings, there are various types of loadings that can be accommodated in the software, including distributed loads, point loads, and seismic loads. And these loads may be drawn graphically and are easily added to the boundaries of the software. It's common in the industry to use a pseudostatic method for seismic analysis considerations in a slope. And the pseudostatic method is very common. It has a number of advantages in that it's very simple and direct. It's simple to implement in the context of a limit equilibrium analysis, and it's easy to implement. However, there's certain drawbacks to this method in that it tends to give you an unrealistic slip shape that is very deep. It applies an equal force that's the same with any depth, which is not that physically realistic. In reality, the forces, the accelerations due to a seismic event decay as you go down in the ground. And so it's been criticized as being not necessarily that closely aligned with reality, but it is a simple method to use. And so there's also not a lack, or there's a lack of consensus in terms of what coefficients to put into this type of analysis. So there's a little bit of lack of consensus on how valuable this method is in the industry. So as a result, PLAXIS, the Soil Vision and subsequently the PLAXIS LE team has collaborated with a university in Canada to implement a more comprehensive method called the spectral seismic analysis. And this method allows a decaying function as the key thing of the force application with depth. And this has been shown to be much more realistic in terms of aligning the factor of safety to a fully seismic finite difference or finite element analysis. As can be seen by the pictures in the lower left, use of this function greatly helps the accuracy of the analysis. And so we were happy to do this as a collaboration with the university in Canada. There's also a finite element seismic analysis module that can be utilized for solving dynamic scenarios. And this can be used in conjunction with the limit equilibrium software. There are also many support methods that can be implemented in the software, such as grouted tiebacks, end anchors, soil nails, micropiles, and geotextiles. So what are some of the differentiating features? The software's been able to differentiate itself against known software competitors in the market. And this just, maybe we'll talk about some of these features here. So the software was positioned really to be a comprehensive slope stability analysis package, and therefore it offers a number of advanced differentiating features, which include simplified 3D model creation using Plexus Designer. Even if the end result is still a 2D analysis, the package allows comprehensive spatial analysis of a 3D site. which is useful. The software also implements advanced unsaturated flow and the ability to model climate boundary conditions in detail such that you can consider actual evaporation in your analysis. Software also allows calculation of rapid drawdown scenarios. Advanced probabilistic analysis is put in the software, as well as advanced spatial variability calculations. There's advanced searching methods using dynamic programming, and the ability of the software to model the stability of rock slopes has been greatly enhanced through the use of bedding planes and advanced anisotropic soil strength models. The software also integrates with PLAXIS FEM and is useful for sharing models between finite element and limit equilibrium. So just to talk a little bit about Plexus Designer, it's a three-dimensional geotech conceptual modeling software that enables 3D compilation and visualization of geotech information to improve design. It allows conceptualization of many different data sources to give a comprehensive 3D site view of existing conditions of future designs. So we used it a number of times for different projects in-house as well. So it allows fast 2D spatial stability modeling, which greatly reduces modeling times. And so instead of analyzing and agonizing over which slice that you want to analyze in 2D, you can now sweep your slices around a 3D model and analyze tens or hundreds of them and get an idea of how the spatial stability varies depending on what slice you take in your 3D site. So just as an example, here's a tailings dam, and we're applying multiplane analysis across this earth structure on the upstream and the downstream side of the structure. So traditionally in this structure, you'd take maybe 1, 2, 3, or 4 different sections at different places. In multiplane analysis, you can take hundreds of sections up and down a slope, and every section is a full 2D analysis and gives you a much better idea of how the factor of safety can change depending on where you're analyzing in your structure. So this gives you a very comprehensive way to sweep your analysis and gives you more data at your fingertips as a designing engineer to make educated decisions of your true minimum factor of safety. You can also consider pore water pressures and the complex topographies or internal geostrata can be considered in this paradigm. Unsaturated climatic analysis is possible with built-in finite element seepage modeling in the software, and you can implement unsaturated constitutive models and allow the consideration of unsaturated conditions such as rainfall events and how those affect the slope stability of a slope. And this makes use of the Wilson-Penman method to calculate actual evaporation from a soil surface. So, and those methods are coupled really between the seepage analysis and the climatic boundary condition, and then the how that impacts the unsaturated shear strength of a particular typical scenario. So rapid drawdown is also implemented in the software. It can identify pore water pressures may build up behind a slope and cause slope instability. Software allows analysis of rapid drawdown conditions both in a total stress or effective stress manner, and the effective stress manner allows coupling with finite element seepage analysis. There's advanced probabilistic analysis, including Monte Carlo, Latin hypercube, and the alternate point estimate method. And the alternate point estimate method, as can be seen in this slide, allows generation of a tornado diagram, which what it does is it identifies the relative impact of each input variable on the ultimate factor of safety. So in other words, the variables at the top have the most ability to sway the factor of safety. And so you can determine the relative impact of various model inputs. So spatial variability can be considered in greater detail in the software through the use of random fields. So in this methodology, soil properties can be varied across the region domain in a random fashion, such that there is an influence that can be properly quantified. So you can integrate this with probabilistic analysis to such that there's a different random field generated for every iteration of a Monte Carlo analysis, for example, and you can do very advanced probabilistic analysis. So dynamic programming is another method that was developed, and my father worked on this a number of years ago, and there is research that he based this further research on that was done both in Japan and in Israel. And so this is an interesting new method that looks at, it's the traveling salesman algorithm to try to hunt for a minimum slip surface through a stress field. And therefore your slip surface does not have to be circular, it can be non-circular, and it's proven to be a very powerful method in finding your critical slip surface. There's also advanced block searching features that have been implemented where we can reference a number of different shapes in the software, such as points, lines, or grids, and those can be hinge points to find your most critical slip surface. There's also a number of features in the software to handle rock mechanics and associated features such as weak surfaces, anisotropy, bedding guides, and weak surfaces can be interpolated between the bedding guides. So complementary to this, there's a number of constitutive models that can support rock mechanics types of implementations. Those include anisotropic linear models and Barton Bandus, Hook Brown, common strength, rock strength models. There's also PLAXIS integration with PLAXIS LE integration with the PLAXIS Finite-Element software, and you can transfer limit equilibrium models to the PLAXIS LE software and reanalyze them using the shear strength reduction method to get a comparison for how that compares next to your limit equilibrium analysis. So just, typical applications that we go through, there's earth dams and levees that can be used to find a factor of safety in various design scenarios or in rapid drawdown. You can look at embankments and roadways that are either reinforced or unreinforced. In this case, we have a road structure that is placed on a slope with fill, and then to further strengthen the slope, there's reinforcements that are put in the form of anchors or micropiles. And this also just shows an example of using random fields and varying a certain layer, the material properties, in this case, the friction angle of that layer, to see the impact on the factor of safety. And then you have the resulting non-circular slip surface that is estimated for this scenario. So overall, the benefits of the PLAXIS LE 2D software can be summarized really as follows. So the software allows comprehensive building and conceptualization of 3D site data using Plexus Designer. There's also access to advanced statistical methods to quantify variability. And there's comprehensive searching methods to give an improved chances of finding the true minimum critical slip surface. So there's comprehensive analysis of unsaturated slopes, integrated finite element seismic and groundwater analysis, as well as the ability to export models to the PLAXIS finite element software. And thus it's a very comprehensive tool for slope stability analysis. So at this time, I would like to turn it over to Facile, and he can provide a specific overview and demonstration of the software. So Facile, it's all yours.
Thank you, Murray. And welcome everyone to this webinar. So let me start by opening Plexus LE Connect Edition. So when we open Plexus LE, we are greeted with this screen. which shows that we can either create a new model, create an existing, open an existing model, or go to the Plexus Manager. So let's say I want to go to the Plexus Manager first of all. So here, these are all the distribution models and all the models that you have saved yourself will be showed in this manager. So when you download Plexus LE, you are provided with all these models, which are some are benchmark models, some are actual projects. So these are arranged in 2D or 3D or 1D format, or you can also arrange them in the form of slope stability, Plexus Designer, groundwater, dynamics, that way. So let's, and here at the bottom, you will see the preview of the model, which one you select. So let me go here and just filter out the 2D models. So now it's only showing all the 2D distribution models. So I will select a model right from here. Say I'm going to select this simple slope, which is supported by anchors or soil nails. So the first thing you'll notice is the scale and the grid and the X and Y axis of this graphic user interface. Also at the bottom, you will see here some CAD features that are useful in creating your model. Your grids can be turned on and off, snapping of objects can be turned on and off, and as well as sticky and ortho options are there. Now, because this is a distribution model, we cannot make changes in it. So we have to save it into our own folder. So I'm going to save it here as slope excavation. And now you see that if you go in the top, you will see that you have this menu bar option as model, and we start by going into the settings. Here we can select the slip surface to be from left to right or from right to left. In this case, our slip direction is going to be from right to left. We can define the shape as circular, composite, or non-circular. So here we're going to define non-circular. And the search method can be specified as fully specified or cuckoo search or any other one. So right now we are selecting block search method. We can also use optimization for the slip surfaces in case your slip surface is not going to be a circular one. So calculation methods for the limit equilibrium, we can use Bishop, Jumbo, Fredlund, and for convergence, we have these settings to have number of slices to be displayed and the tolerance values, which we can adjust. If we want to do a probability analysis or a sensitivity analysis, we can do that by clicking here. And similarly, for a seismic analysis, we can enable it from here as well. Also, we have these design standards inbuilt in the program. So we have 4 Eurocode design approaches and 1 British standard, as well as you can input your own factors here. So if you are doing applying some load factors, you can do that from here as well. So we press OK. So next is the materials. So right now, if we go to the material manager, you can see that there is one material that is assigned here, Amherst clay. And also in the GUI, graphic user interface, you can see it's displayed in a box here with its properties displayed here. So if I double click on it, I will open it and I can edit its properties to whatever I want. Say I'm going to use these. And I'm also going to create a new soil layer. Say it's sandy silt. And from this drop down, I can select various material properties that I can assign. I can assign unsaturated properties. You can have bedrock. You can even have no strand water, Hawk brown materials for rocks. You can have more Coulomb, linear elastic, bilinear, or even power curve functions, as well as shear normal function, which you can define for your material strength. So let's go here and select a color and use Mohr Coulomb model for a new material. Just assign a random cohesion and friction angle and unit weight. Press OK. So once we define the materials, we can go ahead and also we can create regions. So if you go to geometry and regions, right now, if we click here, we see that we have only one region assigned or created in this model. So if we go to geometry and we go to regions, we'll see we have just one. So we can create a new one and we can assign the material from here, or we can first create the region here by going to geometry and clicking on draw region polygon and say we have a layer here. We will just draw this layer right here. Or maybe we have something on the top as well. So we go here, geometry, draw region polygon. Say we have a small layer over here, like a small load over here. And so if we want to assign the materials, we can just right click the region, apply material, and we can assign the materials right from there. So you can have as many layers as you want. So the next step is to define your slips, which we defined initially in the model settings to be block search. So if we go here, we can go and click on block search here. So we have different options here for this search method. You can use your own fixed points, or you can use random generated points. You have to define your left and right projection angles, the exit angles for the slip. So here we have defined it as point and lines. See here, the line is highlighted. So if you want to know more about any of the feature, you can any of the features in the program, you can just go to help, Plexus user manual. And here you can say type, I want to know more about the block search. So I will type block search here and double click here. So it will bring up information about this method. So here you can see you can specify the block search as a point in which the slips are forced to exit to this point, or you can have a block or a line or a polyline. And these lines can be subdivided into different segments, and all those segments will be considered as slip lines to exit from there. Also, we can go to pore water settings then, and here we can establish our water table by drawing it, or if we have results from a groundwater analysis, we can import that result file as well, or we can do a result file linking in which you can link your groundwater results with the slope stability analysis, so that if something changes in your groundwater model, the results will be automatically updated in the slope stability model. So let's say we have a water table, and I'm going to select all regions in which it will apply. So I can assign the coordinates of the water table, or I can just draw it. For simplicity, I'm just drawing it right now. Say it's going like this. It's okay. So we got a water table. The next tab here is the loading. So if we go to loading, we can add line load, distributed load. So right now we just added a point load here. And the next step is going to the supports. So here you go to the type manager. And here we can see the two soil nails are defined here. And if you go to the properties of the soil nail, you will see that the pull-out strength, you can define in kilonewton per meter. You can apply the force application as passive or active, and the capacity and spacing can also be defined here. And here, if you go to the support geometry, you can define the supports. So here we have support 1, which is being highlighted here. And if you click on support 2, it's highlighted over here. Or you can create a new one. And instead of being individual, you can have like multiple supports from the boundary. So right now its orientation is defined normal to the boundary. You can have it horizontal, or say you want it at an angle of -20 degrees. And you want it as a soil nail. And then you have to select the segment. Its length, say 5 meters. And number of supports are say 3. So I'm going to choose a segment here. So it will create my supports like that. And okay, so if you go to the type manager, you can create a new support as well. And these are the options that are available. For example, you can have end anchored, geotextile, gravity type X, soil nails, micropiles, and even user defined support as well. So once you have your supports and their proper strengths assigned, your soil layers, your slip circle, you're ready to do the analysis. And you can just go ahead and press analyze, save it. So it's calculating from using the Bishop, Jumbo, and GLE that we selected. And now we can click on visualize results. We can see that the critical factor of safety using the block search method is 1.6. Here in this window, you will see the slope information for the sliding mass. You will get the weight and the volume of the mass, area, and its entry and exit points over here. Also, if you go up to this menu, you will click on slip and you can say show slices. So these are the slices. And if you click on any slice, you can get the information of the forces. And if you double click, you can get more detailed values of that slice. For example, you can get the base friction angle, base cohesion, base normal force, shear stress, left normal force, and everything. And you can then export this diagram as well for your reports. And you can also export this data as well for reports. And you can select any of the methods from this top-down menu as well. So we got our Plexus LE model here. Now, for example, now I want to do a stress analysis and I want to do it in Plexus 2D. So for that, I can open Plexus 2D. And we will import this model into Plexus 2D for stress analysis. So I'm going to create a new project. Slope. Okay. Now here, if I go to the file menu, we can go to import Plexus 2D LE. It will ask me to start the remote scripting server. Press yes, start the server. Press close. Now here it's saying select Plexus 2D LE model. If I click on it, I can select from any of the distribution models, or I can just browse it. So this is the model that we have, slope excavation. Press OK. So it's converting. So it says the model has been loaded, and now it's asking whether I want just the geometry or all supported properties. So I will select all supported properties from here. Press import. So our structure has been imported, as well as the materials. So these are the supports. Now the supports in Plexus 2D. If you go here into the from the show materials, you will see that the immersed clay and the sandy silt are imported as soils. And if you click on the type, you can go to embedded beam row. And so your soil nail has been imported as an embedded beam row. And we can then define the properties and do a finite element analysis of this model. We can then go forward and create the mesh, flow conditions, and then in the stage construction, we can add your stages and do the finite element analysis. If, on the other hand, we want a Plexus 2D model to be imported in Plexus LE, for that, what we can do is that we can go to the file and we can export geometry from here. And it will be exported as a DXF file. So in Plexus LE, you will import it, or you will import only the structures or the soil polygons, and then you will have to assign those materials to your geometry in Plexus LE. The other thing that I wanted to show is MPA 2D model and how to go from a 3D to a 2D Plexus LE model, and from there you can go to a Plexus 2D model as well. So for example, here I'm just going to show the 3D models in Plexus Manager. And I'm going to select, say I'm going to select this model here. So this is a 3D model in which the multiplane analysis is being carried out. You can see that different 2D slope, slip circle, slips are generated, as well as grouted tiebacks are assigned, are modeled for the slope to support the slope. So here, just to quickly go through the output here, because creating this model and everything can be will require a separate webinar. But if you go to the input first, you can see that when you are in the 3D model, you can go to the model and you have this option of multiplane analysis. But to get that, you go to model and settings, and here in the multiplane analysis, initially it's disabled, then you enable it from here. And then you can then define your multiplanes. So let's quickly go to the output, and here we can see we have our combined critical sliding mass here. So if we go to the slips here and critical sliding mass, we can actually explode this mass right here. So this is our critical sliding mass, and this information gives us the areas and volumes and weight of this mass, and as well as the resisting forces. So if we click here to the SD view, we can actually look at slice by slice. So in the Y direction. So this is also a very useful tool we have. Now, if we want to go from this 3D model to a 2D model, what we can do here is we can go to the file, save as, and instead of 3D, I'm going to say 2D from a vertical slice. So I'm going to give it a name, 2D model of this. And then in the spatial tab here, I can make this section in X or in the Y. We can see visually that how it's generated, and then we can move it with this slider as well, or we can give it the exact coordinate over here. So let's say I am here and I want to create a section right over here. I can press OK. And we get our 2D section from that 3D model. And then we can analyze this separately, or we can modify it, add some more supports or whatever we want. And then the same way that we did previously, we can save this model and then go back in Plexus 2D like did before, and we can import that model for a stress analysis again as well. So I hope this was informative in terms of giving an overview of the overall workflow of Plexus 2D. So thank you very much. So now I will stop sharing my screen.
Thank you, Faisal.
Sure.
Thank you very much. Maury, we can move to the questions now.
Sure. Are there any questions here at this time? I know we've gone through a lot of material at a very abbreviated time frame, but we're happy to answer any questions that you might have. I'll give you a minute to just look over and see if there's any questions you can think of here.
מי שיש לו שאלה ומעוניין לשאול, זה הזמן המתאים.
Yes, I guess you can enter the questions on the team chat as well there. I got one. Let's see here.
איילת, המיקרופונים שלהם משוחררים, הם יכולים לדבר?
כן, עכשיו אפשר להפעיל את המיקרופון.
אוקיי, מי שמשתתף והמיקרופון שלו סגור ורוצה לשאול שאלה יכול לפתוח אותו ולשאול את מורי או את פאסל בשמחה.
Hello.
Hello.
This is Daniel. First of all, thank you for the very interesting webinar about the 3D limit equilibrium. Approximately how long does it take to make this calculation? Is it minutes, hours, or approximately, of course? Yeah,
we were worried about that when we developed the software, that it would be take a lot of time next to 2D. But that's the benefit of 3D analysis with limit equilibrium, is you're only doing calculations on your failed portion of your slope in 3D, not the whole model domain like in finite element. So the calculations are very fast. Like, that's the reason we use 2D limit equilibrium, is because the calculations are very fast. Same thing with 3D. So a typical model, typical model will take in 3D, a simple model, just 30 seconds, a couple minutes, something like that. If you do a very comprehensive model, it might take a few hours. I mean, the most comprehensive analysis we ever did of an open pit with millions of trials, slip surfaces around a huge 3D structure was in the order of 2 days. 2 to 3 days. So that's, most analysis are 30 seconds to, a couple hours would be typical, and that's depending largely on how many trial slip surfaces you choose to have done. So it's very fast.
Okay, good news.
Yeah. You can also go if you download the software, the trial version, and you look through the folder or the project that says Slopes 3D, all the analysis times for all of those models are recorded, and you can see them in the manager view that Facile showed us earlier.
Thanks.
Yeah, great question. I think that's one of the reasons why 3D analysis is a nice possibility, is because it's easy to set up now. It used to be hard. Now it's quite easy to set up. And the analysis doesn't really take significantly longer time in terms of, if you're waiting 10 seconds as opposed to 30 seconds, it's not a big difference. Yeah, great question. Any other questions? I'm looking out past my window to a whole bunch of snow, and I realize here in Canada, you probably don't have snow over there.
חברים, עוד מישהו מעוניין לשאול משהו, או שאנחנו... רחל, אני רואה שרחל רוצה לשאול, רק המיקרופון שלו...
No, I don't want to ask anything. It just, you caught us in the one day that we had snow in March, but only in Jerusalem, so...
There you go.
The one time that it happened was today. But it's a new software. We need to do the trial and then probably have a lot more questions. So
yes, and that's probably a good thing, that the trials can be downloaded and evaluated for 7 days, I think it is. And we would welcome supporting you with trials. There is new training that is available on the software that's been posted on the Bentley site here. And I'll just copy that link to the chat window here so that you have access to the videos here. Let's copy this, and I'll put this in the chat window here. There. And so there is a series of about 14 different training videos that has just been posted on YouTube.
If I may, I have another question.
Yes,
if I got it right, not all of the soil models in PLAXIS, you got them in this LE program. For example, hardening soil. So
yes.
How do I solve that if I have a model with the hardening soil and then I want to make a limit equilibrium?
Yeah, that's a great question. The key thing you have to remember is in limit equilibrium, there is no consideration of deformations. So it's, by definition, it's limit equilibrium. So some of the models can't be supported in limit equilibrium because they're based on strength as the soil deforms, such as the hardening model you mentioned. So you would have to translate that to basically a peak strength or a residual strength model that can be represented in limit equilibrium. So that's one of the key differences between limit equilibrium and finite element, is how you approach it. With finite element, it's a deformation technique that therefore you need a more complex soil model that includes how does the strength change as the soil deforms, which is great and more comprehensive, but it's also more complicated to implement. And we've done a number of studies. I mean, in most cases, in terms of the factor of safety, the results between finite element and limit equilibrium are very similar.
Okay, thanks.
But yeah, great question.
if I do a model in PLAXIS 2D, and I calculate a factor of safety there. What is the benefit of your software? Just the fact that it's simpler, or?
It's simpler. It translates into 3D much better. It's very difficult yet to do a 3D finite element analysis. You can model factors of safety below 1.0, which it's very difficult to do that in finite element. You can do probabilistic analysis, which probabilistic analysis is very difficult to do in finite element due to the long execution times. And spatial analysis, it's better. Limit equilibrium is better to sweep an analysis through a spatial area to find out what is your variance of your factor safety versus the, versus space. So there, you learn different things is the way I would put it. I wouldn't view one as better than the other. You learn there are different type of analysis, and there's good points and bad points to both. I would suggest what we're trying to encourage within Bentley is, as much as possible, do both analysis and you learn different things through the process of modeling the stability of a site two different ways.
Okay, thank you.
Yeah. Any other last questions?
חברים, שאלות אחרונות, אם יש, זה הזמן, אם לא, אנחנו כבר מסיימים. Okay, it seems we don't have any more questions. So,
Good.
Thank you very much.
We're happy to do this, and if there's more questions that come out once you download the software and try to solve some problems, myself or Facile are happy to help in any way we can.
Great. אם מישהו כמובן רוצה פרטים נוספים, מוזמן לפנות אליי, לשרון. אני ארשום את הפרטים שלי בתיבת צ'אט, את המספר טלפון שלי גם. וכמו ששמעתם, אם יש עוד שאלות או דברים נוספים, אתם מוזמנים לעלות ולפנות אליי גם. Okay, so I think we're done. Thank you very much again. Thank you, Faisal. Thank everyone join us today.
All right, thank you very much.
Thank you so much.
Thanks. Our pleasure to be here. Bye-bye.
Great.
Bye.
Great. Thank you.
Bye.
Bye.